Welcome, everyone. In the next 30 minutes, we'll walk through a piece of CephFS history. The talk is divided into three parts. I will go through a very quick intro on Ceph and CephFS, then releases of Ceph after it was declared stable, and then we'll make some consideration on Ceph evolutions. First of all, I work for the ETH Zurich, which is a university founded in the mid-1800s. It's been a driving force of industrialization in Switzerland, and it's one of the leading universities for technology and the natural sciences. It currently gives employment and place of studies and work for around 30,000 people from 120 different countries. The reason for its success is that can be traced back to an excellent education, groundbreaking fundamental research, and also the fact that there is a very active knowledge transfer that benefits society. I'm part of the Scientific IT Service at the University of Zurich. It's a section of the IT services, and it's composed of about 40 experts in various areas of scientific computing, with a different, diverse scientific background. So let's dive into Ceph and CephFS. So this paper, many of you can probably recognize. It's one of the papers that Sage wrote while he was doing his PhD thesis at the University of California. It's also one of the three papers that I got handed when I started playing with Ceph in 2017 by a colleague. I find very, very remarkable that together with Rados and Crash, the third paper was actually about a scalable high-performance distributed file system. So Ceph indeed had a file system in its DNA from the very beginning. Some interesting dates are the InkTank startup that developed Ceph, starting from 2011, joins the Linux Foundation in 2012, and then it's acquired by Red Hat in 2014. What about Ceph releases? So Ceph releases after Orgonaut, that was released in 2012, changed their cadence after Luminous. So we can see the Ceph releases were initially meant to be around twice a year, and they had like a development and a long-term support release. That actually got changed with Luminous, and the first release, Mimic, which actually had a one-year cadence, and all have had this LTS support. Where is CephFS co-located in the Ceph ecosystem, in the Ceph stack? So it's one of the possible layers on top of Rados. It provides a file system with a stronger POSIX compliance than NFS, and it relies on the metadata server daemons, or MDS. So these are an additional service that needs to be deployed on the Ceph cluster. And while the client still has the ability to write data directly to Rados, the metadata access is mediated by MDSs that are in charge of actually providing this layer of consistent and coherent caching to the clients. They in turn actually use the Rados and the specific pool in Rados to write the metadata there. CephFS had a kernel driver since very early, so since 2010, so with kernel 2.6.34, which is actually well before the Argonaut release. CephFS actually, so this is like a testament to how like CephFS tried to integrate into the Linux ecosystem from a very get-go. And that concludes a little bit the quick intro that I wanted to give. We will now go through the Ceph releases. So just a quick disclaimer. This is actually a very personal selection of changes that affected CephFS during the years. The releases of CephFS are actually overlapping. So sometimes it was difficult to attribute a specific feature to a specific release, also because developers are doing a very good job in backporting changes to active releases. So attribution of features can be not always correct. Ceph was declared stable in 2016 with Jewel, which is the 10th Ceph release. It has still some limitations, so it has non-snapshot support and support a single active MDS. Although it also had a recovery tooling that was declared feature complete, and it also featured an experimental multi-file system support. I recommend this very nice presentation from Gregory Farnham about the Jewel release, and more specifically CephFS in Jewel. It's available at the link in the slides. So Luminous was released the year after in 2017. It features the introduction of blue stores, and this actually makes zero write possible, and it also paves the way to erasure-coded data pools in CephFS. This is very important for the one of us that we're actually looking for a cheaper way to have CephFS or to deploy CephFS, which did not needed to have a replicated data pool as CephRBD, for example, was requiring. However, this blue store introduction is still not a good fit for all the workloads. There are still spiky workloads that actually makes a better use of a file store plus a flash journal. This Luminous also feature multi-MDS availability, so it's now available, but it has no snapshot support. And it also introduced a new upgrade procedure that requires operators to reduce the active MDS to 1 before performing the upgrade. Directory fragmentation is now stable, so large directories are automatically split, so their content can be fetched in smaller chunks, and potentially it can also be served by separate MDSs. And subtree pinning also appears, which entails the possibility to avoid the MDS balancer to move subtrees between MDSs when multi-active MDS deployment is actually in place. Luminous also feature AppMap that allows for near-perfect PGS distribution, allows then operators to actually get the most out of the storage they have available. And there is also the first-time clock prototype aimed at replacing the existing queuing scheduler. Things that are even more interesting with Mimic. So as we mentioned, it's probably the first release that actually follow the new release strategy. But it also features stable snapshot with multi-MDSs, or at least the capability of taking snapshots multi-MDSs. The quota support is available starting from kernel 4.17. And there are MDS stability improvement that allow so namely the throttling of large cache stream, the limitation of clients with a flag to 1 million capabilities, and also the possibility for MDS to evict unresponsive clients if another client requests capabilities that are held by them. There are also 2 CVE fixes in CephX, which in the CephFS perspective is actually the authorization method for clients mounting natively CephFS. Multi-file system and snapshot are considered still experimental and kind of advise against use them together. With Nautilus, which is released in 2019, on the disaster recovery side, we have a new addition for CephFS data scan that can now scan links can now auto repair INO tables and snap tables. There is the ability to to allow only specific clients to manage snapshot, and the throttling and trimming of large caps acquisition, which increase the stability of MDSs that have large cache values and long-running clients. The introduction of CephFS shell gives operators the possibility to manipulate the file system without mounting it. And that's a very interesting possibility because it allows operators to manipulate extended attributes that are used by Ceph for file layouts or for quota without needing an active mount. There is also a new information that arrives from the docs, that is that CephFS default data pool should not be erasure coded. That's a kind of unfortunate news for the operators that deployed the CephFS before then, because then they are stuck with a default data pool which is suboptimal. The reason for the recommendation is that the default data pool still stores the backtrace for every file written in the actual data pool pinned to a specific directory. And this actually means that there is a list and object per inode stored in the default data pool. And those are very, very tiny objects. So having like erasure coded there doesn't help. It's actually harmful for performance. Nautilus also features the ability to apply no-out related flags, so no-in, no-up, and no-down to specific crash entities, and so without affecting the whole cluster. And the introduction of the Messenger v2 Secure that allows for the encryption of all network traffic. And also a change in behavior for scrub and deep scrub that's now aborts the ongoing operation when the flag is set, allowing operators to react faster to possible issues in their cluster. The release of 2020 is Octopus. It features a lot of improvement in the dashboard for CephFS management. It is now possible to perform client eviction, snapshots, quote adjustment, and also browse the CephFS directory. MDS can now be assigned to manage a specific file system. And very importantly, MDS now asks aggressively idle client to trim capabilities. This actually helps to better prepare for successive workloads, for successive requests. And it was very impactful for use cases that we had with similar to HPC kind of use cases. The MGR, so the Manager Volume plugin, features a lot of improvement to support CephFS CSI. And also like there are some interesting things that happen with Octopus. So inline data support is officially deprecated, although some operators use it successfully to improve performance with specific workloads. And there is the introduction of ephemeral pinning with this distributed and random pinning subtree partitioning policy. Pacific, it's released in 2021. It features additional changes that helps MDS deals with production use cases. It can automatically evict clients that are not advancing the request IDs. Its multiple file system are now declared stable. So they actually appear very long ago, but they finally declared stable with Pacific. There are two new manager plugins, the MDS Autoscaler and the Snap Schedule, that allows Ceph ADM to provision MDS to react to changes in the max MDS setting, and the Snap Schedule that allows to schedule snapshot of CephFS. It's now possible to deploy with Ceph ADM NFS gateway clusters in active-active mode, and ephemeral pinning is declared stable. A new daemon is available, CephFS Mirror, that allows to mirror file system to a remote Ceph cluster. On the disaster recovery side, there is now the ability to delete lost and found items after following a disaster recovery procedure. And Windows can connect to CephFS since Pacific. There is like a mechanism similar to Fuse for Windows with a framework called Docan that allows Windows to mount CephFS share. There is the introduction of CephFS Top as a preview, as a new utility to inspect client performance metrics. And then we switched to Quincy. It was released in 2022. One of the interesting things that came up in 2022 was a CVE for CephFS Manila that affected a cluster that upgrade from Nautilus and was fixed and was fixed or backported also in previous releases. From the CephFS perspective, an interesting change is that now standby replay daemon that failed to replay the journal marks the rank as damaged. And the fact that MDS upgrades no longer requires those standby daemons to be stopped before upgrading. There is now also the possibility of creating a specific file system with specific FSCID. Here, the autocorrect actually played a trick on me. And a file system can now be renamed, although all CephX credentials previously authorized need to be actually amended. Reef was initially released in 2023. As I mentioned before, difficult to find attribute all the changes to a specific release. I think one of the things that I found notable is that the latest Reef release actually changed the container images, which are now not compatible with older kernels. Then we can go to Squid, which is the most recent release of Ceph. And here the most notable changes are the automatic metadata load balancer, which is now disabled by default. The possibility to impose write IOs and metadata mutation on a tree, and this actually permit crash consistent snapshot. And the fact that two file system names can be now swapped with a new command, which facilitate disaster recovery. So this there's also the kernel clients disable async direct drops by default. This I find in the release note I found very interesting because it was a feature that I was not aware of, and I had just some difficulty tracking down. MDS log trimming now has a separate thread that tries to trim every second, and the CephFS virtual extended attribute can now be removed without needing to actually set them to the default value. The CephFS journal tool, Journal Reset, received a guard against operating on an online file system with the usual flag. And then, as we heard in the keynotes, there is the introduction of Crimson C-Store, which is unfortunately only available for RBD workloads on replicated pools, so not yet interesting for CephFS. Also, CephFS key rotation is now possible in an automated manner. So this is a very brief overview of what changed in Ceph since it got declared stable. The architecture, on the architecture perspective, designing a CephFS cluster is a task that increases in complexity over the years. It gives a lot of latitude to the architect to actually devise the optimal hardware and configuration setup. Of course, this flexibility brings a lot of responsibility as well. The introduction of Ceph ADM with Octopus facilitate the test phase, allowing to test and benchmark many configurations with ease. And it also allows to work around the single-threaded nature of MDSs, making very easy to provision multiple MDS on the same bare metal host. This helps optimize CPU usage in modern multi-core systems, and consequently the metadata IOPS. However, CephFS as always depends on the performance of the Rados layers underneath, and the success of the deployment. It always depends also on how the design is tuned to the production workloads that the Ceph cluster needs to take care of. From the bootstrap tooling perspective, the Ceph being an open source project had from the very beginning very many tools built by the community to ease the bootstrap and managing of the system. And they lived in addition to the one supported officially, like Ceph Deploy and Ceph Helm. Some of these are Ceph Ansible, DeepC, which was based on Salt, and we were using Salt underneath, Puppet Ceph, and Ceph Mon, which used Juju. The introduction of the Ceph ADM in Octopus changed profoundly the landscape. Several tools were actually abandoned, others were refactored as wrapper around Ceph ADM, and new ones were also created. Rook appeared to provision CephFS on Kubernetes, Ceph Salt as a wrapper around the Ceph ADM, and then this open-enable SCI cluster mechanism. So regarding day two operation, operators, of course, would like to be left alone. So the best storage system is indeed one that manages itself. And the Ceph has always been notable in this regard, with features like automatic rebalancing in case of no device failure, periodic scrubbing for data consistency, and the switch to run Ceph on containers and the possibility of having upstream testing the images actually meant that in addition to a dramatically simplified upgrade procedures, it also curbed the issues with distribution packages bugs. It also started consolidating the user base around the shared container images, giving the potential of making reporting and debugging issues easier. On the CephFS perspective, however, the system management is still firmly in the operator's hand. Forward online scrubbing is available without limitation, but also without a built-in scheduling mechanism. Occasional bugs can still trigger file system failures, in particular during upgrades. And more importantly, at least for us, the lack of a detailed feedback from the system after a recovery operation does not really give peace of mind when multi-petabyte file systems are at stake. On the disaster recovery side, I'd just like to spend a few words. So there are indeed a series of tools that have been available since Jewel, and they are constantly improved. They can help in addressing and eventually recovering a faulty file system. They are very powerful. The error handling, however, is not very friendly. And they come with a big disclaimer that they can do more damages as well as fix issues. Of this tool, I would like to mention two, CephFS journal tool, which allows to rebuild metadata that exists in journal but is lost on disk, gives the ability to inspect, import, export, and reset a journal, and it has also a feature to actually extract metadata from a damaged journal. And CephFS data scan, which is a backward scrub, which iterates through all Rados objects, recovering missing metadata objects that may have missed following a disaster, maybe missing. So with this, I actually finish what I wanted to present to you. Thanks for your attention, and if you have any questions. So thanks, everyone. If there is anything, I'm anyway available at this email address. And thanks again.